The very first time that you see something, you think that is how things have always been. What you see the first time sets your mind for that's what a coral reef is. Something is very badly wrong on the reef. It is wrong because the conditions in which corals grow have changed and are continuing to change, and those changes are increasing in their impacts on the biology of corals. I don't want to be a person who sees the end of my career as being, thank goodness it's the end of my career because the system I work on is dead. I want to walk away saying, I did everything in my power. Every time you step outside in Hawaii, you know that you are in a place that has such extraordinary natural beauty that it sort of reminds you, it's in your face all the time. You never forget that you're immersed in nature here, and either above ground or under the water is exactly the same. You just jump in the water and there's hundreds of things to see.
When tourists come out here to see the reef, they see a bunch of kind of colored rocks. It's my job to explain to them that those rocks are actually amazing living organisms, and that these organisms are closely related to jellyfish. They live in colonies that have an indeterminate lifespan and indeterminate size. What that means is that they can grow to enormous sizes and enormous ages. Unless they're killed by something, they'll live forever and grow forever.
So the first time I saw a coral or a coral reef was really on a PowerPoint slide. What I responded to in that moment was this apparently extremely complex image that showed what looked like all different sizes and shapes of rocks, really. But actually, these were ancient organisms, animals that are 200 million years old, that have this exquisite ability to harness the biology of other organisms, in this case a plant, and that when you put those two things together at the microscopic level, that would enable biology that would create reefs that you could see from space.
So I like to say that corals are to reefs what trees are to a forest. The trees provide all the animals in the forest with food and shelter. That's what corals do to reefs.
It is such a good analogy. You talk about the birds. In this situation, then the birds, the fish, these gorgeous colored fish that spend much of their life or just a short period of their life in the reef. You think about just the bottom itself. There's loads of algae that live on the bottom of coral reefs. There are so many other things on the reef apart from corals. And it is this feature, I think, of the reef and the rainforest that is analogous. The corals just create the place where other things convene. They are meeting places. It's a bustling city. We see high rises, we see low rises. Those would be equivalent to the different species. Some species grow up, some species go across. Some species have hundreds of other organisms living in them, and some species have just one or two. And in between, you've got things running down the road. We've got bicycles, we've got cars. Think of it all. Think of what a city is like, and that's what a coral reef is like. What the corals do that is so unique is they are able to intimately associate with these unicellular plants that live inside their cells. So I'm going to say that again. These plants live inside their cells, which is an incredible evolutionary advance. This is an astonishing thing that we call a symbiosis. And inside the animal cells, these plants do what all plants do. They are able to draw down carbon dioxide that we breathe out, use sunlight to join it with water, and in doing so, they produce a small sugar, a food, and oxygen. And those plants then feed the animal from within. So the animal essentially has a food factory living inside of it. This relationship enables the coral themselves to secrete the structure, the skeleton that forms the reefs, that create the habitat in which hundreds and thousands of other species live. People estimate that 25% of the biodiversity that you find in the ocean has at one time or another spent a moment of time on a coral reef. And there's this astonishing figure that 70% of the protein that's eaten in Pacific Islands comes from the reef. 70%. If there's no reef, there is no protein in those places. The majority of people who live in Hawaii live very close to the water. And sea level rise is now threatening the land masses that are not surrounded by reefs. We're seeing erosion of the North Shore. We've seen collapses here on Oahu of roads. If the reef is there, a healthy reef has a good chance of growing quickly enough to accommodate sea level rise, to protect the land mass. The lack of that reef, it's inevitable what will happen. We will lose land. This is why the trickle-down effects of reefs, their death, will affect every single person on the planet.
We first noticed bleaching here in Hawaii in about September 2014, and that really was a wake-up call to us. We always thought that Hawaii, being a higher latitude reef with cooler water further away from the equator than many coral reefs in the world, we thought we were more resistant to bleaching than other areas.
Hawaii is a great example of how much things have changed and how quickly they've changed. We have had two back-to-back bleaching events, one in 2014 and one in 2015, both of which have been extensive. That's unprecedented. Here in Kaneohe Bay, it was pretty distressing to see what happened. We had essentially 70% of the corals on the reef in 2014 here in Kaneohe Bay turned white. There were alerts coming in from all over the state now. I happened to visit a friend of mine in Kona, and I went snorkeling on the reefs I couldn't believe what I was seeing. It was a field of white corals. I talked to dive operators who've dived that area for 19 years, who have never seen anything like what happened. Unfortunately, the reports from those people are that many of those corals died. Corals are these organisms that actually have this plant living inside of them. These millions of plants do their thing. They photosynthesize like all plants do inside the animal. And that photosynthesis is a set of biological reactions that occur within a given range of temperatures. So what happens when a coral bleaches is that range of temperatures in which these activities can take place is exceeded. And when that happens, it damages the cellular machinery of these tiny plants. And when that machinery is damaged, it can no longer produce food for the animal. And what that animal perceives then, it starts to see this, we think, as, ooh, I've got something foreign inside me. I've got to get rid of it. And it starts to dump these plant cells. What you see when a coral bleaches is a dark brown coral gradually become paler and paler as it starts to dump these cells. When it goes completely white, it's essentially got rid of its entire population of plants. What you see when you see a white bleached coral is the skeleton that is bright white, showing through translucent animal tissue. And that is a living but fully bleached coral. The coral has thrown out its food source and is now starving to death. Whether that coral dies is a race against time.
Many corals can recover from bleaching. They need time and the right conditions to be able to recover. Without the down years in between, if we're getting bleaching every single year, year after year after year, that just makes the bleaching more and more devastating.
The environment is warming and becoming more acidic at rates that are exceeding the capacity of reefs to naturally adapt to the changes. The warming and the acidification, the changes in the overall water chemistry, we believe, and I believe, are a direct result of fossil fuel burning. The conditions that drive bleaching will be more frequent because the overall temperature is rising. And so the spikes in temperatures are now what are actually driving all the bleaching events, these natural variations that just occur because you're coming from a degree or two warmer than you were. We've already really warmed almost a degree. Let's face it, that's what we've done to the planet now.
The coral reefs are just the first of ocean ecosystems to collapse with climate change. They're almost like the litmus test for the rest of the ocean. And once a coral reef collapses, the rest of our ocean ecosystems will fall like dominoes.
When you talk about coral bleaching, there are global events, and we are currently in the third global coral bleaching event. Corals in multiple locations will be bleaching and potentially die. And to give you an example, the first global bleaching event was in 1998, and it caused the death of 16% of the world's coral reefs. Here we are in the year of the third global bleaching event, and there was extreme bleaching in American Samoa. There's been extreme bleaching taking place in other locations, and now currently in and on the Great Barrier Reef.
I first came here in 1982, so a really long time ago, and it was the most beautiful place that I'd ever seen when I came here. And it stayed like that most of the time. Cyclones naturally occur here, crown of thorns outbreaks occur naturally here. Reefs can bounce back from that, and they're generally locally small-scale things. I'm of no doubt that reefs can be terribly resilient. They can bounce back from what appears to be almost terminal decline really quickly, given the right conditions. And we know what those conditions are. They need clean, clear water at the right temperature. So given those things, reefs will bounce back. In early 2016, we had the massive coral bleaching following on from other parts of the world, and that got everything. Everything that was left from the cyclones was got by the bleaching. We lost a huge proportion of the corals in the northern third of the Great Barrier Reef. That's hundreds and hundreds of square miles of coral reefs, the biggest coral reef in the world. The landscape changed very dramatically within a very short period of time when the corals died, from being beautiful, vibrant, living coral gardens to dead coral skeletons covered with algae. The state of the reef right now is worse than I've ever seen it. I've never seen it anywhere near as bad as it is now in this area. What is happening now is happening really, really fast. Ocean acidification hasn't really kicked in yet. We're seeing the effects now of global warming. Ocean acidification is from the same ultimate cause, too much carbon dioxide in the atmosphere, but it's a completely different process. And we're not really seeing the effect of that yet. The effect of that is likely to be animals are not able to build their skeletons as well and as strongly as they were able to when carbon dioxide was not as high in the atmosphere and in the ocean. By the time we start seeing that, it's going to be way too late to do anything about it. It's just so insidious. By the time you see it, it's all over. What I've really noticed since the bleaching is the number of tiny coral colonies that are now starting to grow. I'm a glass half full person rather than a glass half empty, and every time I see that, it makes me happy. We're looking at evolution in fast forward about 1 million times here. If we continue to get coral bleaching on increasingly short intervals, there's no way that it can survive. There's no way that the reef itself can survive. I'm really pessimistic about that, unless we do something really quickly to curb our carbon dioxide emissions. It's a place we've never, ever been before.
When people say to me, what can we do about it? We can all contribute to the issue of mitigating fossil fuel burning. Can we do it? Will we do it? Will the planet do it? I don't know the answer to that question. It's really interesting if you actually look at bleaching. You see huge variability in the way in which individual coral species respond, in the way that individuals within species respond. There will be coral reefs that are extremely badly hit by bleaching. That means almost every individual on the reef will turn white, and many of those individuals will die. A reef right next door could potentially not bleach as severely, and those corals that do bleach might fully recover. And a question that is really a current question is why? Why do we see so much variability in the susceptibility of different individuals within species, and different reefs to bleaching? Things are happening and changes are occurring on the reef that I, as a biologist, can't just stand by and watch. There are individuals that are surviving, and what if we could take a better understanding of why those individuals are surviving? What if we could give corals experiences that conditioned them for future ocean conditions? We should be thinking about how to adapt reefs to climate change. That adaptation is really through a part of science that we call assisted evolution. That is really trying to help nature and to speed up the rate at which nature adapts to a given setting. Corals that survive bleaching maybe imprint a memory of having experienced that stress, and the next time they see a stress similar to the one that they've survived, they just don't see it as a stress any longer. We need an endgame strategy to help Mother Nature. Obviously, people would say, well, you can't possibly do that at a scale that could make a difference. And what I would say is, what we're testing is, can it be done? And if it can be done, then let's think about what we would need to do on the reef itself to create experiences that would have an effect at the scale of a reef. What if we understood that, well, if you warm a coral for 48 hours, 2 degrees, that it stimulates this memory, and that's all you need to do? Could we go out and deploy a rig that would warm a reef 2 degrees for 48 hours? Could we do that in situ on the reef? I think the answer to that is yes. I know many engineers who'd love that challenge. It's not a perfect solution, and I don't think we even know what the answer's going to be, but we're certainly walking down that road of asking, how could we do it? What should we do? Can we selectively breed corals? The answer is yes, we can. Can we tweak the symbiosis a bit to make the tiny plants feed their animals a little bit longer or stay in place a little bit longer? Can we do that? I think we probably can. Have we ever approached our science that way? No.
I absolutely think that we're running out of time. It's unfortunate, but my generation and those younger than me might just have to tell our grandchildren what a coral reef was rather than see it.
What happens if we do nothing? We will lose coral reefs. And when those coral reefs go, we will have people who starve. We will have people who no longer have a place to live. That is going to happen if we do nothing. Things are changing on reefs so fast that if we don't do something fast, we are going to be left completely disarmed by the impacts of climate change. I believe that there will be reefs in the future, but they will not look like the reefs of today. The reefs will go from being these garden-like places, these things that we analogize, to the rainforest, to boulder fields, where there's much less space for other organisms to be in. In my opinion, it is a very bad outcome. What is the risk of doing nothing at this point? The risk of doing nothing is the risk of risking every reef on the planet.